Hi, and welcome to our tutorial on databases. Today, we will be talking about NoSQL. NoSQL is a non-relational database management system and is used for big data and real-time web application. The name NoSQL can be quite a bit confusing due to the fact that SQL can be used. A better term to describe this would be not only SQL or non-relational SQL. The term was created by Carl Stoss in 1998. Now, how exactly does this work? Traditional relational database management systems uses SQL syntax to store and retrieve data for further insights, whereas NoSQL database system encompasses a wide range of database technologies that can store structured, semi-structured, unstructured, and polymorphic data. The next question would be, why would we use NoSQL? Well, the concept of NoSQL databases became popular with internet giants such as Google, Amazon, and Facebook. These companies store quite a bit of data, and as such, large data centers are required. These data centers become quite expensive. As a result of large databases and complex relationships, system response times would increase drastically for the large volumes of data. To resolve this problem, companies would normally scale up their systems by upgrading existing hardware such as RAM and data storage capacities. This process is quite expensive, so another plan had to be made. The alternative to this is to distribute data over multiple hosts when the load increases. This method is known as scaling out. The term of scaling up requires upgrading components such as RAM, CPU, and physical storage space. This implies a lot of overhead costs for a company. Each scaling method has its own advantages and disadvantages. Next, we will be talking about some features of NoSQL. Well, we said NoSQL is a non-relational database management software. This means that it never follows the relational model. It works with self-contained aggregates or blobs. It doesn't require object relational mapping and data normalization. This also means that there are no complex features like query languages, query planners, relational integrity, joins, and so forth. NoSQL databases are either schema-free or have very relaxed schemas. NoSQL databases also provide better implementation of simple API. It provides companies with important information and reports to ensure efficient management. NoSQL databases can also be highly distributable, which in effect means better failovers and better auto-scaling capabilities. NoSQL databases offer a variety of technologies which helps with the processing and displaying of data. These technologies can include key value, graph, document, and column store techniques. Over the course of this video, we will define and compare several of these technologies to each other.
Graph databases versus relational databases. What is a graph database? Graph database is a database that consists of vertices and edges. They use the graph data model to work with and store relationships and data. They effectively highlight links similar to the way we do. They are also schemaless. Graph databases have some pretty cool features, like due to the fact that they store the relationship along with the data, these relationships can simply be read from storage, eliminating complicated and expensive joins. They can also highlight relationships that we previously would maybe find a bit more difficult to see. Now let's see some differences between graph databases and relational databases. Relational databases needed schema to be defined before new data can be added, while graph databases are schemaless, allowing for more flexibility. Relational databases organizes its data into tables with each a specific format, while graph databases forms new tables and data columns according to relationships. Relational databases use joins to perform queries, while graph databases avoid joins and focus on relationships. Relational databases can be scaled vertically, while graph databases can be scaled horizontally. Relational databases are efficient when data correctness is important, while graph databases are inefficient where fast data retrievals are important.
Comparison between document and graph databases. Document databases is an example of NoSQL databases. These databases store each individual record and its related data in its own document. It is known as document stores that are primarily used to store semi-structured data in JSON document format. These databases increases coders' productivity for storing and retrieving the data to and from the database by using the same document format that they use in their code. Document databases offers a schema that are flexible and sometimes referred to as schemaless. The data in a document database has a tree-like structure where links are used to connect different data objects. Document databases are essentially used for big data purposes as well as content management. Since the schema is flexible, it is therefore capable for storing any type of data based on your needs. Examples of document databases include MongoDB and Apache CouchDB. Graph databases, on the other hand, is based on graph theory. These databases make use of nodes to store data entities and edges that stores the relationship between these nodes. The data stored within these data entities are represented in key value pairs format. Since the nodes are physically linked in the databases, by accessing these relationships, it provides immediate access to the data itself. Graph databases can also be characterized in terms of not using a predefined schema. Graph databases is mainly used in means to serve as a backbone for social networking platforms, for building and provision of a knowledge graph, as well as for fraud detection. Examples of graph databases include Neo4j and Amazon NetTune.
I'm going to compare traditional SQL database and a document database. A database is a collection of data. It is also the relation of data. A relational database stores data of an entity represented by a two-dimensional table consisting of rows and columns. A relational database relates the entities to one another through entity characteristics that is commonly shared. A document database stores data in key value pairs. The value component is a tag-encoded document. The database groups documents into logical groups called collections. A document can be in any encoded format, for example XML, JSON, or BSON. The collection of data is related by a tag, which is a named portion of a document. Other differences between a document database and a traditional SQL database is a document database is schemaless, whereas the traditional SQL database always will have a schema. The data in a document database isn't normalized, whereas the data in a traditional SQL database normally is normalized. The document database doesn't store relationships between data objects, whereas the traditional SQL database stores relationships between data objects. The document database has an eventual consistency because changes are made on a replica of documents and the retrieved replica of a document may not have been updated yet, whereas traditional SQL databases is immediately updated. So it has a strong consistency. Other similarities between the two databases is both document databases and traditional SQL databases can retrieve data based on specific queries. With a document database, data requested through a query can be retrieved based on the content of tags. This is possible due to the DBMS's awareness of tags within documents with a balance tag that has the value of 0.